Hello, in this video we're going to go through Learning Target 432. This is going to be part 1 of our notes, which is on calculating theoretical and experimental probabilities. Today we're focusing on theoretical mostly, but we're going to define both. So probability in general is the likelihood of something happening. The likelihood of something happening. So the probability of there being a snow day, or the probability of if you flip a coin, if it's heads or tails. It's just the likelihood that something will happen. So then there's two types we're going to focus on of basic probability. One is theoretical and one is experimental. So theoretical, like it sounds, is in theory what should happen. So like we talked about already this unit, we have these mathematical models that say what should happen in a perfect world. But that's not always how things actually happen. So theoretical is, in theory, what should happen based on mathematics alone. And to find that probability, so capital P stands for probability. In parentheses, we put what we're finding the probability for. So this one, like probability of whatever event we're looking for, is equal to the number of desired outcomes, so what we want to happen, over the number of possible outcomes. And then experimental is what actually happens in a trial or experiment. So theoretical, for example, in theory, if I flip a coin, every other time I should get heads and then tails, and then heads and then tails, and then heads and then tails, because there is a 50% chance of getting each. And then experimental is like what actually happens when you are flipping a coin. So if I flip a coin 30 times, I can figure out how many times I actually flip heads versus tails. And then the formula to find that one is almost exactly the same, but this is like actually what happens. So the number of times the event occurs over the number of total trials. Now let's look at some examples of this basic probability. So the first one, each letter of the word probable is written on a separate note card. The cards are placed face down and mixed up. First, is this theoretical or experimental? Now, the way to tell the difference is there an experiment where you have data of what happened? Like someone is actually pulling a note card and you have data of what letter gets pulled each time. We don't have that, so this is theoretical. This is in theory what we are trying to find. So then part B, what is the probability that a randomly selected card has a vowel? So to find our probability, we want the number of desired outcomes, so what we want, which is a vowel, on top of the number of possible outcomes. So our desired outcomes are vowels. Looking here, we have vowels of O, A, and E. So there are 3 vowels. That's what we want. The number of total outcomes is 1, 2, 3, 4, 5, 6, 7, 8. And this answer needs to be in a percent. So if it asks for a fraction, we would be done. It would be 3/8. However, if we want to find a percent, we have to convert it to a decimal and then a percent. So this is equal to 0.375, which is equal to 37.5%. So we have a 37.5% chance of pulling a vowel. Part C, what is the probability that a randomly selected card has a consonant? You can give your answer in a fraction. So we can do this by the exact same way we did it here, where we can find the number of consonants, which are everything that's not a vowel. So 1, 2, 3, 4, 5. Again, we know we have 8 letters total, and it said a fraction, so this is the answer. You could also look at your previous answer because these are mutually exclusive. So if it's not a vowel, it has to be a consonant. If there's 8 total and 3 are vowels, we know there's 5 letters left. So you can also use like the opposite of this. And this is our answer. So I want you to try this next one. Push pause, try it, push play when you're ready to see the answer. And here we are. So the number of desired outcomes is 7 are perfect. There are 12 songs total. 7 over 12 gives us this decimal, which is 58.3%. Moving on. So on the back, we are going to do a little bit of a different type of example. So it says the game Battleship is played with 5 ships on a grid with 100 holes. Players try to guess the location of their opponent's ship and sink each. A, with your very first guess, what is the probability that the first shot hits any of the pieces? Give your answer as a percent. So these are the pieces and how many holes they cover. So if we're trying to find any piece that gets hit, our desired outcome is whatever this is added up. So 2 plus 3 is 5, plus 3 is 8, plus 4 is 12, plus 5 is 17. So 17 favorable outcomes or desired outcomes, and then it tells us there are 100 holes total. Anything over 100 is pretty easy because this as a percent is simply 17%. 17 over 100 is 17%. Next, it asks the probability that it hits a submarine specifically. So our number of desired outcomes is only the submarine pieces, which only covers 3. Again, we have 100 total. And it wants this answer as a decimal. So 3 divided by 100 is 0.03. And we can leave it like that. All right, you're going to pause it and do this you try. Remember that a die has numbers 1 through 6. So you're going to answer A through D and then push play when you're ready to see the answers. All right, and here we go. The probability of it being a 1, there's only one desired outcome. 1 out of 6 is 16.6%. An odd number would be 1, 3, or 5. There's 3 outcomes over 6, which is 50%. Less than 4 would be 1, 2, or 3. Again, 3 over 6 is 50%. And anything besides a 5 is 1, 2, 3, 4, and 6. So that's 5 out of 6, which is 83.3%. So you can go ahead and end this video and work on practice for probability.